till now we were not taking into account the effect of friction and all losses which will occur when the melt is going to flow till the corner, from the pouring basin till the corner of the mold. So now we'll take all those losses which can occur. So let's define the aspect ratio as L by D, that is the length by the diameter of the sprue. Next, V bar is the average velocity, length L is the length of the pipe, D is the diameter of the pipe. EF1 is defined for friction loss, which the formula is given as 4F L by D V bar squared divided by 2. And this value of F is the friction coefficient, which is equal to 16 by RE. R is the Reynolds number, which in case it is laminar, which is less than 2000, then we use the value of friction coefficient as this 16 by RE. In case the flow is turbulent inside the sprue, that is the Reynolds number greater than 2000. In this case, the friction loss coefficient, the friction coefficient F value can be figured out from this. This now is an implicit equation where the root F is appearing on the left hand side and right hand side also. This type of equations can be directly solved in your calculator, the scientific calculator. So do make use of that calculator. Do not keep on solving manually. That's what I want to say. The EF2 is all the losses which are occurring because of the change in area. Inside the mold also the area is going to change when it is going to enter from the sprue basin, sprue or the pouring basin inside the sprue, from sprue to the gate, from gate to the mold, and terminating. That is when the melt is reaching the corner, all the boundaries. That is when the velocity is going to get to zero. Whenever 90-degree bends are occurring, 180-degree bends are occurring, all at all these situations, there are going to be losses in the energy of the fluid, and that's what we are going to take account of. The EF2 value will be half into EF V bar square. V bar square by beta is defined as friction loss. The earlier was also a friction loss. Over here also we are telling it as friction loss, but remember these are the things which are occurring because of this 90-degree bend, 180-degree bend, etc. Beta is the coefficient which is a constant which should be given. Now we'll write the equation again between the location 1 and location 3. But at the location 3, we are having some extra losses. All the energy is not available in the fluid. This is the energy in the fluid plus the losses which have occurred, EF1 plus EF2. Now all the things, EF1 and EF2 which we have defined, will be entered in this equation. I have entered. The extra terms goes off, and this is what we have finally. Okay. This is the simplification is simple. It's not that tough. Okay. So this bracket remains as it is. V3 square is equal to 2GH, the bracket, and V3 is equal to CD. So this denominator is taken over here, and the other factor remains as it is. So now CD is defined as coefficient of discharge, defined as -1 by root 2, -1 by 2. That means 1 over square root of this value. Okay. Please respect the minus sign over here. CD will be 1 over square root of the thing which is over here. Okay. This comes inside the square root. Yeah. Okay. And in bands, L by D has to be taken as L by D equivalent. So there could be multiple bands, and before the band and after the band, there could be a change in length or change in the diameter. In that case, L by D equivalent will be given to you, and use that term. So CD at finally will be 1 upon beta plus EF plus 4F into L by D plus L by D equivalent, the whole raised to power 1 by 2. So that's the coefficient of discharge, and that can be directly used now in the V3 term, and V3 term will be useful. V3 is equal to the velocity at the gate, and that will be useful to find out the mold filling time. Okay. In the previous video, I forgot to mention one thing. In the top filling, the time was 21 seconds. In the side filling, the time was 43 seconds. So make sure if the geometries are same and all the other factors are remaining same, the mold filling time for side filling will be larger than the top filling case. Okay. Thank you. Do make note of this formula, that will come handy. Thank you.